Hi mga ka-learners! This is David Emmanuel Ricaplaza from the BsMath 1-A studying at Cebu Technological University main campus. And now, we are going to talk about one of the methods of proof, which is the direct proof. Now, are you ready to learn? Let's get started. First, we are going to define what is proof. In mathematics, proofs are arguments that convince the audience that something is true beyond all doubt. In other words, a proof is a presentation of logical arguments that explains the truth of a particular statement by starting with the things that are assumed to be true and ending with the statement we're trying to prove. A proof is a clear and well-written argument, and just like the story, it has a beginning, middle, and end. So since we already know what is proof, I assume that we can easily understand what is direct proof. A direct proof is a logical progression of statements that show truth or falsity to a given argument by using theorems and definitions and others. Direct proofs always assume a hypothesis is true and then logically deduces a conclusion. And now we're going to talk about its structure. As we stated above, all proofs have a basic outline, the beginning, middle, and an end. The beginning is where we assume something to be true and by stating definitions and necessary theorems. The middle of our proof will include statements, each following logically from one to the next that will lead the reader to the end. The end is our conclusion and the statement that we are trying to prove. To understand more about this structure, let me give you an example. These two examples are valid claim and invalid claim. Our examples are using the method of direct proofs. So the first one is its claim is the sum of any two odd integers is even. So going back to the structure, we are to start at the beginning. So in the beginning is where we assume something to be true by stating definitions and necessary theorems. So in this claim, we assume two variables, the m and n. So we assume m and n are two odd integers. With the definitions of odd integers wherein m is equals to 2a plus 1 and n is equals to 2b plus 1 for some integers a and b. So basically the definitions of odd integers is 2n plus 1. The reason for this is if you substitute any integers to the variable, the answer or the result will always be odd. So let's say for example, we are to substitute the variable n to an integer which is 9, then 2 times 9 is equals to 18 plus 1 is equals to 19, in which it is an odd integer. So even if we will use an even number to substitute the variable n, the result will always be odd. Since the claim is the sum of any two odd integers is even and we assume m and n be the two odd integers, therefore it is m plus n. Using the definition, m plus n is equals to 2a plus 1 plus 2b plus 1 is equals to 2a plus 2b plus 2 and factor to 2 times a plus b plus 1 is equal to 2k, where k is equals to a plus b plus 1 is an integer. Since 2k is a definition of an even integer wherein any integer substituted to the variable k, the result will always be an even number. Then m plus 2 is equals to 2k is an even integer. Therefore, we can conclude that the sum of two integers is even. So next is the invalid claim. For any positive integer, m, if m is prime, then m squared plus 4 is also prime. We can prove this by using counterexample. Since it is invalid, then therefore we will prove this that it is false. So what is a counterexample? A counterexample is just one example showing the claim to be false. So let's see how we would use a counterexample to refute a claim. Basing on the structure, so we begin with assuming. So assume m is equals to 2, which is a positive or prime integer. Examples of prime integers are 1, 2, 3, 5, 7, and so on. Then it follows that m squared plus 4 is equals to, since the m is equals to 2, so 2 to the power of 2 plus 4. Then 4 plus 4 is equals to 8. So however, since 8 is a composite number, not a prime number, this is a contradiction, and we have shown the claim to be false by counter example. So that's all for my video, guys. I hope you learned a lot. Thank you for listening. Bye bye.